following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to go on and cover section 11.2, which talks about, among other things, inverse functions. But before we talk about inverse functions, I want to talk about the idea of a one-to-one function. Okay, let's see here. And we're going to go down here and take a look at these two mappings, so to speak. All right, so in the first mapping, we have the inputs and the outputs, the domain and the range. We see that 2 goes to 9, 3 goes to 4, 7 goes to 4, and 10 goes to 3. So this is a function. For each input, there's exactly one output, but it's not a one-to-one function, since 3 and 7 both go to 4. A one-to-one function means that every domain value goes to just one range value, and every range value comes from just one domain value. If we look at the second set, we see here, this is a one-to-one function. -4 goes to -2, 0 goes to 6, and 8 goes to 3. Likewise, -2 only comes from -4, 6 only comes from 0, and 3 only comes from 8. If we have a function that is a one-to-one function, it also has an inverse function. The inverse function is basically going back the other direction. So the domain becomes the range and the range becomes the domain. The best example I can think of is temperature conversion from centigrade to Fahrenheit or Fahrenheit to centigrade. If you take a centigrade value or a Celsius value, it takes you to one specific Fahrenheit value. That specific Fahrenheit value takes you just to the one specific centigrade or Celsius value, so it goes back and forth at a one-to-one relationship. Now, I want to look at some graphs. This is the graph of a linear equation. If it is a one-to-one function, it not only is a function, meaning it passes the vertical line test, which this one does, but it also passes a horizontal line test. So this is the graph of a one-to-one function. This next one, which is a cube root function, it passes the vertical line test, so it's a function. It also passes the horizontal line test. Sorry, bad drawings. Okay. This sad-looking parabola is a function, but it is not a one-to-one function. It fails the horizontal line test. This square root function, again, passes the vertical line test and passes the horizontal line test. So this is a one-to-one function. This horizontal line is a function. We say it's a constant function, but it's not one-to-one because it fails the horizontal line test miserably. This is a function, but it's not a one-to-one function. So for a function to be one-to-one, its graph must pass both a vertical line test and a horizontal line test. All right, now let's take a look at an equation, a function in fact. It says f of x equals 2x plus 4. This is a one-to-one function. Since it's a one-to-one function, it has an inverse that is also a one-to-one function. I'm going to take you through the steps involved in converting a one-to-one function into its inverse function. All right. Step number one, we're going to rewrite f of x using just regular equation notation. So we're going to replace f of x with y. Okay, that's step number one. Get rid of the function notation. Step number two, we're going to interchange x's and y's. All the x's in the equation become y's. All the y's in the equation become x's. So this becomes x equals 2y plus 4. The next step is to solve for y. So step number 3 is to solve this equation for y. Let's see. I'm going to subtract 4 from both sides. So I'm going to get x minus 4 equals 2y. Then I'm going to divide both sides by 2. So I get x minus 4 over 2 equals y. I'm going to just rewrite this equation by interchanging the left and right sides of the equation. Y equals x minus 4 all over 2. That's just for my own sanity, so to speak. I want to have my y on the left side of the equation. Nothing fancy there. And then step 4 is to rewrite this inverse function using inverse function notation. So we're going to replace y with f inverse of x. Now, this notation looks like f of x to the -1 power, so you might think of 1 over f of x. That's not what this notation means. This means that this is the inverse function of f of x. All right. So again, the 4 steps. Step number 1, we replaced f of x with y. We interchanged all the x's and y's. When we did that, we now have created the inverse function. Step 3, we solved for y. And step 4, we replaced y with f inverse of x. Okay. Let's take a look at another example. F of x equals 2x plus 6 divided by 3. All right, so this is a one-to-one function. We're going to find its inverse. Step number 1, replace f of x with y. Step number 2, interchange all the x's and all the y's. Step number 3, solve for y. To do that, I'm going to multiply both sides by 3. So I get 3x equals 2y plus 6. I'm going to subtract 6 from both sides. 3x minus 6 equals 2y. I'm going to divide both sides by 2. 3x plus 6 over 2 equals y. I'm going to rewrite it with y on the left side. And then step number 4, replace y with f inverse of x notation. Okay, so this is the original function. This is the inverse function. All right, let's clean that up a little bit. Let's take a look at some ordered pairs for both this function and its inverse. Okay, so let's see. The original function, f of x equals 2x plus 6 all over 3, 2x plus 6 all over 3, and the inverse function is 3x minus 6 over 2. 3x minus 6 over 2. So again, let's make a table of some ordered pairs for this first function. I'll tell you what, let's start with 0. When x is 0, f of 0 would be 2 times 0, which is 0 plus 6 is 6. 6 over 3 is 2. Okay, so f of 0 would be 2 times 0 plus 6 over 3. which is 6 over 3, or 2. Okay, how about, let's see, let's use 1. F of 1 would be 2 times 1 plus 6 over 3, which is 8/3. And 2, F of 2 is going to be 2 times 2 plus 6 over 3, which is 10/3. And 3, F of 3 is going to be 2 times 3 plus 6 over 2, which is 12 over 2, or 6. Okay, so those are some ordered pairs that are solutions to this first equation. All right, now let's find some ordered pairs for the inverse function. And for x, I'm going to use what may seem like some strange values, but I'm going to use 2, 8/3, 10/3, and 6. Okay, so F inverse of 2, let's see here, F inverse of 2 would be 3 times 2 minus 6 over 2, which is 0 over 2, which is 0. F inverse of 8/3 would be 3 times 8/3 minus 6 over 2, which is 8 minus 6 over 2, which is 2 over 2, which is 1. F inverse of 10/3 is 3 times 10/3 minus 6 all over 2, which is 10 minus 6 over 2, or 4 over 2, or 2. And F inverse of 6 is going to be what? 3 times 6 minus 6 over 2, 12 over 2, which is, wait a minute, I messed up there. Let's see, 18 minus 6. What did I do wrong? Hang on here. Okay, I found my mistake. My mistake was actually back here, where I wrote F of 3 equals 6 plus 6 over 2, and it should have been over 3, which is 12 over 3, which is 4. So then over here, I want to find F inverse of 4, which is 3 times 4 minus 6 over 2, which is 6 over 2, which is 3. And of course, by now, hopefully you've noticed that the domain of the original function is the range of the inverse function. The range of the original function is the domain of the inverse. So all the ordered pairs are interchanged. Why? Well, during the process of finding the inverse, the second step was to interchange x and y. Okay, so that's how that works. All right, now let's take a look at a function and its graph. So I'm going to pause things again. Right, we'll start the recording back up. And now we should be seeing the graphing screen. Hopefully that's what you're seeing. And let's take another function. Let's see here. Yeah, let's do this one. F of x equals 5x minus 1. Okay, so what we're going to do, first of all, we're going to find, get rid of that line, we're going to find the inverse function. Okay, so y equals 5x minus 1. Replace f of x with y. Interchange x and y. X equals 5y minus 1. Solve for y. So I'm going to add 1 to both sides. X plus 1 equals 5y. Divide both sides by 5. x plus 1 over 5 equals y. I'm going to rewrite that. Y equals x plus 1 over 5. And then finally use inverse notation. Okay. All right. Now, let's take f of x equals 5x minus 1. And let's find some ordered pairs to use to graph this thing. How about x is 0, 1, 2. We'll just use 3 points. That's enough. Okay. So f of 0 would be 5 times 0 minus 1, which is negative 1. F of 1 would be 5 times 1 minus 1, which is 5 minus 1, which is 4. F of 2 is 5 times 2 minus 1, 9, 10 minus 1, which is 9. Let's plot those points. 0, negative 1, 1, 4, 2, 9. And let's draw a line through that. Okay. All right, now let's take f inverse of x, and in fact, we could go ahead and just assume, based on what we did before, that those points would be solutions. Okay, so if I plot those, negative 1, 0, 4, 1, and 9, 2, I get this line. Okay. Now, I also want to add another line, and I'm going to make that one in red. And let's see if I've got this lined up correctly. Here. Oops, I forgot to make it a straight line. Okay, let's try this again. Let's see here. That should do it. Okay. Now, I want to make this a dotted or dashed line. Okay. So this is the line y equals x. This first one is f of x, and this is f inverse of x. What I want to point out is that graphically, a one-to-one function and its inverse are symmetric about the line y equals x. So in fact, I could have graphed f of x and then graphed y equals x and then just reflected across the line y equals x to plot points for f inverse of x. Okay. All right. Let's see here. I want to do another thing with these two functions, f of x and f inverse of x. Okay. So let's see here. We're going to go to the next page, and I'm going to have to recopy. So I got f of x equals 5x minus 1. Okay. So f of x equals 5x minus 1. And then f inverse of x equals, let's see what it was, x plus 1 over 5. X plus 1 over 5. All right. Now, if two functions are inverses of each other, we can compose them in both directions, and in each case, we should get x. So we talked about the other day that composition of functions was not commutative in general, but specifically a one-to-one function and its inverse function, when you compose them, you should get x in both directions, which is another way of verifying that they are or are not inverse functions. Okay, so we're going to do that. So let's take, let's see, f composed with f inverse of x. All right, that's going to be f of f inverse of x, which is f of that x plus 1 over 5. So we're going to put x plus 1 over 5 in the place of x here. So it's 5 times the quantity x plus 1 over 5 minus 1. All right, well, simplifying, the 5s would reduce out, giving us x plus 1 minus 1. The plus 1 and the minus 1 reduce out, and we get x. So composing them in that direction, so far so good. Now let's take f inverse composed with f of x. That's f inverse of f of x, which is f inverse of this 5x minus 1. So we're going to put 5x minus 1 in the place of x in that function, giving us 5x minus 1 plus 1 all over 5. Well, we could combine like terms in the numerator. Minus 1 plus 1 becomes 0. So now we've got 5x over 5, reduce out the 5s, and we get x. So these two functions are inverses of each other. The proof is that when we compose them in both directions, we get x. All right. I want to look at one more example. So let's see here. We're going to do that and that. And here we have the following. F of x equals x squared plus 1. And then it says off to the right in parentheses, x is greater than or equal to 0. Okay? So let's take this function and find its inverse. Step number 1, replace f of x with y. Y equals x squared plus 1. Step number 2, interchange x and y. X equals y squared plus 1. Step number 3, solve for y. I'm going to subtract 1 from both sides, so I get x minus 1 equals y squared. I'm going to go ahead and turn it around and write y squared equals x minus 1. But now, to solve for y, what would I do? I'd have to take the square root of both sides of the equation. And when I do that, I'm going to have plus or minus the square root of x minus 1. And then going on from there, I'm going to replace y with f inverse of x notation. So we get f inverse of x equals plus or minus the square root of x minus 1. Well, there's a problem. Okay, let's go back up here to the original function. That's a parabola opening upward, the y-intercept, or the vertex is at 0, 1. So basically, it's going to look, let's see, 4, 5, 6, 7, 8, 9. That. Let's get my handy dandy graph or tool here. Let's see if I can draw a decent picture of that. And maybe. Anyway, well, what's the problem with that? It's not a one-to-one function. It would fail the horizontal line test. But there's a restriction applied to that function. It says x is greater than or equal to 0. So by restricting the domain on this function, we're getting rid of this piece, okay? Because over there, x would be what? Less than 0. So we're going to get rid of that piece, okay? Now, what we have is a one-to-one function, okay? Now, what about this? It says plus or minus. Well, recall that the domain of one function of a one-to-one function is the range of its inverse. And the range of the one-to-one function is the domain of the inverse. Getting myself mixed up there. Okay, so if for this function x is greater than or equal to 0, for this function y has to be greater than or equal to 0. Well, if y is greater than or equal to 0, that means y can't be negative, which means we're going to get rid of this negative sign because that would negate all of the outputs, all of the y values. Okay. Now let's graph this. F inverse of x equals plus the square root of x minus 1. We don't need the plus, it's implied. Okay. Well, let's see here. We'll go ahead and keep this in red. And let's find some values. How about if I let x equal 1? Okay. So here, f inverse of 1 would be the square root of 1 minus 1, which is the square root of 0, which is 0. So we're going to get 1, 0. How about if x is 2? F inverse of 2 is the square root of 2 minus 1, which is the square root of 1, which is 1. So 2, 1. And how about 5? F inverse of 5. Oops. F inverse of 5 is the square root of 5 minus 1, which is the square root of 4, which is 2. So 5, 2. So what am I getting? I'm getting this graph, okay, which is symmetric with the other graph about the line y equals x. Okay, so in review, if a function is a one-to-one function, its graph not only passes the vertical line test, showing that it's a function, but it also passes the horizontal line test, showing that it's one-to-one. There is a four-step process to find the inverse function of a one-to-one function. Step number 1, replace f of x with y. Step number 2, interchange x and y. Step number 3, solve for y. Step number 4, replace y with f inverse of x using inverse function notation. Ordered pairs that are solutions to the one-to-one function. If you interchange the x's and y's, you get solutions to its inverse function. If you graph both functions on the same grid, they should be symmetric with each other about the line y equals x. And finally, if you compose a one-to-one function with its inverse in both directions, you should come up with x. And there you have it, folks. All righty, so I'm going to stop the recording, and I'll be back at 1:15 if you have any questions. Have a great rest of the day. Bye now.